Welcome to qnawire.
This tutorial goes through the process of solving question 32 from chapter 6, section 6. We're told to solve the equation x times the quantity 4x minus 11 equals 3. This is a quadratic, so the first thing we have to do is we have to put our quadratic equation in standard form, which is ax squared plus bx plus c equals 0. So we're going to distribute x times 4x, which is going to give us 4x squared. Then we're going to distribute x to negative 11, which gives us negative 11x equals 3. Standard form requires that our quadratic be set equal to 0, so I'm going to subtract 3 from both sides, and this will give me my quadratic in standard form, which is 4x squared minus 11x minus 3 equals 0. Now that we have our quadratic in standard form, we can factor it. Now, because our quadratic has a coefficient for the a term that is not 1, this is going to take a little bit more work than a quadratic that has 1 as the coefficient of the a term. So what I have listed in red are the factor possibilities for the a term. And then in blue, I have listed the factor possibilities for the c term. Next to the quadratic equation, I have the FOIL pattern, or the factor pattern for the quadratic equation. The first two terms that we're going to multiply of the factors are the a term and the c term. The last two are the b and the d. When we multiply these first two, they have to equal 4x squared. And so you'll notice that this is going to come from these factor possibilities, and that this is going to come from these factor possibilities. Now, how do we figure out which ones to use? Well, we're going to look at the signs in the quadratic equation. Because our c term has to be negative and our b term has to be negative, that means that one of our factor terms is going to have an addition and one is going to have a subtraction, because the only way to get a negative product is to have one integer be positive and one integer be negative. And because my b term is negative, that means my larger factor number or factor term is going to be in the subtraction or the negative factor. So I'm going to write that this is going to be a plus b times c minus d. Well, fortunately for us, there's only one factor pair for the c term. That means I know that my c term is going to come from a positive b and a negative d. And that negative d is going to have to be the larger of the two. So this negative d is going to be replaced with a negative 3. So instead of subtracting d, I know this is going to have to be minus 3, because the larger factor the larger factor of 3 is going to make it possible for our b term to become a negative 11x. And that means that my plus b is going to use the remaining factor and is actually going to be plus 1. So now that I have that, I need to figure out which factor pair for my a term I'm going to use. Well, what I need to look at is which of these combinations is going to get me negative 11x. Well, it's either going to be 4 and 1 or 2 and 2. So if my a term is 4, I'm going to be multiplying it by my d term. So that would be 4x times negative 3. Well, that would give me negative 12. And then if I multiply my 1 times my c term, which would be 1, that would give me positive 1. Well, negative 12 times plus positive 1 is negative 11. So fortunately, the very first try has given us the combination we're looking for, which is negative 11x, because this would be negative 12, and this would be positive 1 x's. We put the x in there. And negative 12 plus positive 1 is negative 11. And you can look and see how this wouldn't work with any other factor pair. So if we use the 2x times 2x, well, then we would be doing 2x times 3. And 2 times 3 is 6. And then we would have 1 times 2x, which is just 2. And 2 and 6 is only going to give us a difference of 4. And so that's definitely not going to work. So now we have factored, I'll rewrite this in the parentheses now. We have factored our quadratic. And since we now have our quadratic factored, we can solve. So to solve a factored quadratic, you're going to put each factor equal to 0 and solve it as if it were its own equation. So our first factor is 4x plus 1. We'll set that equal to 0 and solve as if it were its own equation. The inverse of adding 1 is subtracting 1, so we'll subtract 1 from both sides. That will leave us with 4x equals negative 1. And the inverse of multiplying by 4 is dividing by 4. So we will divide both sides by 4, and we will be left with our solution for x, which is x equals negative 1/4. And then we will set the second factor, x minus 3, equal to 0 as well, and do the inverse operations. The inverse of subtracting 3 is adding 3, and we are left with our solution, x equals 3. So the answer, or the solution to this problem, is that x is going to equal negative 1/4 and 3. And since these are the x-intercepts, or where the graph is going to cross the x-axis, these are actually coordinate values. So the coordinate where the graph is going to cross the x-axis is negative 1/4, 0, and 3, 0.